In this video, we're going to be looking at what's called interval notation as well as solving inequalities. So you may not be familiar with interval notation, but it's something that's often used in some higher level math like calculus. So instead of writing things as an inequality with our greater than or less thans, we can use an interval. So an interval, we always go in order from smallest to largest value. And we've got two types of intervals, I guess 4 types that we're going to go through. The first one is what we call an open interval. So an open interval would go along with an inequality where we're not including the endpoints. So something like x values between a and b. And so in our interval notation, we go from smallest to largest. So the smallest value is a and the biggest value is b. And because we are not including either of the endpoints, we're going to use parentheses to indicate that. So you'll want to be careful. This does look like a coordinate. So anytime you're using an interval, you want to pay attention to directions. It'll probably say something like on the interval, and that's your clue that it's an interval and not a coordinate, right? So we could also have a closed interval. So with a closed interval, now we're going to include those endpoints. So now we're saying the x values between a and b, but including them. So the endpoints are still the same, a and b, but because we're including them now, we're going to use what's a square bracket instead of the parentheses. So a little bit different notation. And then we've got 2 different types of infinite intervals. Okay, so if you've got x values being greater than a, when we think about smallest to largest, a is going to be that smallest value. And as we get bigger, because we're greater than a, the biggest thing we could get to is we can't really get to it is infinity. So when we're listing our interval as smallest to largest, our smallest value is a and our biggest value is infinity. Now a is not included here. It doesn't have the line underneath. So it's going to use a parentheses. But the other thing to consider is infinity. We can never reach it, thus we can never include it. So anytime you're dealing with a positive or a negative infinity, you'll have to use parentheses with that as well. So in our interval notation, it would look like a to infinity, where a is the smallest number and infinity is the biggest. And then the last one is if we have something like a less than. So here the example is x is less than or equal to b. So now b is our biggest number. So it's going to go as the second term because we always go smallest to largest. And if we're considering everything that's smaller than that, well, the smallest thing we can consider is negative infinity. So going smallest to largest, we've got negative infinity up until we get to b. Now notice here that b is being included. So b is going to get a bracket, but the negative infinity is going to get a parentheses. So here's kind of the big idea here with the parentheses and the brackets. Parentheses indicate endpoints that are not included, and square brackets indicate endpoints that are included, and parentheses are always used with positive or negative infinities. So they're showing the different notations. Here we've got the interval notation on the left and the set builder notation on the right. So set builder is very similar to our inequality form. It just looks like it's got in curly brackets, and the x that comes first, after that is a vertical bar. That vertical bar means such that. So this first one we'd read as all x values such that x is greater than a and less than b. Okay, so notice here with our inequalities, anytime we are not including, we've got the parentheses, but if we have that line underneath, we're going to have the square bracket that goes with it. So the last thing with that we haven't talked about yet is all real numbers, something we see pretty often. Well, all real numbers means we're including everybody, all the numbers from negative infinity to positive infinity. And so that's our smallest and our biggest values. And since we can't reach either, we put parentheses on both. So we're supposed to express these in set builder notation and then graph. So our first interval is from -1 to 4. And so since it has a definite starting point and a definite stopping point, this is going to be what I like to call a sandwich on the inequality. So the smallest value is -1, the biggest value is 4 for the sandwich. Now our x's are going to be in between that. Now we pay attention to the brackets. The -1 has a parentheses, so we're not including it. So it'll be x will be greater than that. But the 4 has the bracket, so that means we are going to include it. So it'll get set like that. So this is an inequality form. If we wanted to put it in set builder, we would just put that inequality inside of the curvy brackets, right, with the bar. If we think about graphing this on a number line, my smallest value at -1, my biggest value at 4. This says we're not going to include the -1, so it would be an open circle. We are including the 4, so it's going to be a closed circle, and then we just say everything in between. For B, we've got 2.5 to 4. So again, a definite starting point and a definite stopping point, just like the last one. And all our x values are between that. Now, both of those have the square brackets, so they're both being included. We're going to put the line underneath for both. Again, in the set builder, we just stick it inside those curvy brackets with the x and the vertical bar. When I think about my graphing here, starting point and ending point, these are both included, so they both get a closed circle and everything in between. Now for this third one, we've got -4 to positive infinity. So I've only got one definite endpoint of -4, and I know it's on the small end. And so then as I go to infinity, that means everything that's bigger than that. Infinity is positive, -4 is negative, so it's going to be bigger, so it's going to be greater. So this would be written as x is greater than -4. Since it's a parentheses, we're not going to include it, so it's going to stay as a strictly greater than. We can stick it in our bars here for the set builder notation. And it's probably even easier to see this on the number line, because if I draw -4 and I make sure to include everything that's up to positive infinity, open circle, going that way, we can see that it's everything that's greater. So we can use intersections and unions on intervals in finding those intersections and unions. So we start by graphing each interval. I like to do on the same number line. So remember to find an intersection. Think about a Venn diagram. So the Venn diagram, the intersection is just the pieces where you're going to overlap. So only pieces that are part of both groups get included. Versus a union, I like to say everybody gets to come to the party. Anybody who's invited gets to come along. Anybody in either of the groups, everybody's included. So both of these are going to be on the same, we've got the same two intervals, 1 to 4 and 2 to 8. So I'm going to do just the one number line to indicate this. And so I just want to make sure to include each of the different locations that we have here. We've got 1, 2, 4, and 8. So I'm going to plot those. Clearly not to scale, but close enough, right? Okay, so my first interval is from 1 to 4. So starting at 1 and ending at 4. Both of those has parentheses, so they would both be open circles. So positive 1 to 4, everything in between with our open circles. And then our other interval is 2 to 8. Both of those have brackets, so they're both going to get included. So closed circle, and there we go. So for part A, we want to find the intersection. That upside down U means the intersection. So this is the part where we want to see only what do they have in common. So we can see we're looking for the overlap. So where does that start? That starts here at 2, and it ends at 4. So then I have to pay attention to whether we're included or not. So at 2, we can see orange is fine, and green is a closed circle. So we can include the endpoint at 2. But when we look at 4, orange is an open dot. So it's not included, so we can't include it either. We have a parentheses there. Now in part B wants the union. So we just want everybody involved. So that means where do we start and where do we end? So starting at 1, but you'll notice 1 is not included. So we can't include it either. We'd have to have a parentheses. And we're going to go all the way along until we get to 8. And 8 is included, not infinity. 8 is included, so we'll have the square bracket. So 4 is kind of that tricky spot, right? Because it's not included in orange, but it is included in green. And so since we're just saying, even though orange didn't invite 4 to the party, green did. So he's there, and so that's why we get to include it in our interval. All right, moving on to solving inequalities. So keeping it simple with a linear inequality. So our process is going to be the same as if we would for solving a linear equation. We want to isolate the variable, get it by itself, right? So one of the things that's going to be really important anytime you're working with an inequality, this should always be in the back of your mind when you multiply or divide both sides of an inequality by a negative number, the direction of the inequality symbol is reversed. You have to flip your inequality. Just keep it in the back of your mind anytime you're working with an inequality. Don't forget to do that. All right, so we're just going to we're just going to solve. We're not going to do the graphing part. If I've got negative 2x minus 4 being greater than x plus 5, and I want to solve this. So I want to get all my x's to one side. My favorite strategy is to always move over the smaller x to not have to deal with negatives. So my smaller of the x's here is the negative 2. So I'm going to move that guy over, which means if my x's are going to the right, constants go to the left. So I'll subtract the 5. So negative 4 minus 5 is going to be negative 9 is greater than x plus 2x is 3x. We divide by 3. We get that x is going to be less than negative 3. Now, normally we don't like to have the x on the right. So I'm going to go ahead and flip this. The main thing to pay attention to is our chomper needs to be chomping on the correct thing. So since our chomper is chomping on the negative 3, even when I flip this around, I need to make sure it's going the same direction. So x values are going to be less than negative 3. Now, if you want to think about this in interval form, okay, x values less than means we're going to be going smaller, and the smallest that we can go to is negative infinity. So negative 3 ends up being our biggest value. We can never include the negative infinity, and the negative 3 here is not included, so it would get a parentheses as well. Strategy is going to be the same here with a compound inequality. But we still want to get x by itself, but specifically then in the middle. So to solve this one, we've already got x in the middle, so that's good. We want to get it by itself, so we can subtract 1. We make sure to do it to all the pieces. So that gets us to negative 4 is less than 2x is less than or equal to 2. And then everybody gets divided by 2. We get that x has to be between negative 2 and 1, including the value at 1. If we want to put this in our interval form, we have that definite starting and stopping point. So I know I'm going from negative 2 to 1. The negative 2 is not included, so it gets a parentheses. 1 is included, so it gets a bracket. So probably the most annoying to deal with are going to be your absolute values. Because kind of a lot can happen with our absolute value. We're going to start the same way as if you were solving an absolute value equation. The first thing you want to do is you need to isolate your absolute value. That's always going to be your first thing, get your absolute value bars by themselves. Once you do that, then you want to look to the other side of the inequality. And you need to see, is that number positive or if it's negative? If it's positive, it's going to do normal numbery things. But if it's negative, something weird's going on because we know absolute value is supposed to be positive. So let's see what happens first if we have something positive. Once you know you have a positive number on the other side of your inequality, then you pay attention to the inequality itself. So if our absolute value is less than a number, when I think about less than, I think absolute value is representing distance, right? So if I've got a distance that's less than something, there's really not that many distances that are going to be far away, right? We're going to be kind of close together to have those distances be small. So this is where we're going to have what I call that sandwich. We're going to stick the inside stuff of our absolute value in between the negative version and the positive version of the number. Okay, think about that distance from 0 being small. And the other way, if our absolute value is greater than the number, if I'm thinking greater, that's a lot of things. That's either going to be my really big positives or my really big negatives. So I've got two things going in two separate directions. I'm going to have two separate inequalities to deal with. So the first one, we just drop the bars. We'd say that stuff inside is greater than our number. That gets us our really big positives. Or, we have to use that word or. We're going to drop the bars. We're going to do two things. We're going to make our number negative, and we're going to flip the inequality. That gets us our really big negative values. Now, what this part is not mentioning is what happens if we have a negative number on the other side. So what happens if you isolate your absolute value and you're less than a negative number? So first of all, negative on the other side, something weird's going on. Absolute value has to be positive. That's what the definition is. The distance from 0 has to be positive. Well, that means the left side of my inequality here will always be positive. Well, when are positive things less than negative things? Never. It can't happen. So this would look like a no solution. Versus if we have our absolute value being greater than a negative thing. Same idea, my left side there is always going to be positive. When are positive things greater than negative things? All the time. So this one would be all real numbers. It doesn't matter what number I plug in to my absolute value, that left side will always be positive, and positives are always greater than negatives. All right, so let's try a couple of these to finish this off. If we want to solve this, again, I have to get my absolute value bars by themselves. So I'd start by subtracting the 7. So I get -2 absolute value of 3x plus 5 is greater than or equal to -13 minus 7 is going to be -20. Now from here, we're going to divide by the -2. And this is where we have to be careful. Dividing by a negative is going to switch my inequality. So that turns it into a less than or equal to and 10. So my absolute value is now isolated by itself. I see I've got a positive number on the other side. So then I focus in on the inequality. My absolute value right now is less than 10. So I have to think small, less than sandwich. So I'm going to take my number, -10. My stuff inside stays the same, +10 on the other side. And then we get x by itself. So we subtract the 5. And we divide by 3. Oops, I lost it there. Now we divide by 3. And we get our solutions. X is greater than or equal to -5 and less than or equal to 5/3. If we want to put this in our interval form, we've got that definite starting and stopping point. So we're going from -5 to 5/3. Both of those are being included. So we'd get square brackets. And here's the last one. So we are in luck because our absolute value is already isolated. There's nothing outside of my bars. So I look on the other side of the inequality, a positive number. So numbery things are going to be happening. But now I have my absolute value being greater than 7. So now my distances are going to be really big, which means really big positives or really big negatives. We're going to have two separate inequalities. The first one, I'm just going to drop my bars. Now I'm going to flip. I don't like having my x's on the right. So I'm going to flip this. So I have my 5 minus 2x is greater than 7 this way. So I just rearranged the order. My chomper is still chomping on the 5 minus 2x. But the other one I'm going to have, I have the word or, 5 minus 2x. Now I'm going to flip it to be less than, and then it'll be a -7. And so this is what we're trying to solve now. So I'm going to subtract the 5 from both sides. 7 minus 5 is 2. And -7 minus 5 is -12. And then we're going to divide by -2. So we're going to do that carefully, flipping our inequalities on both. So we'll get x is less than -1. Here we'll get x is greater than 6. So those are going to be our solutions. X is less than -1 or x is greater than 6. In our interval form, x is less than -1 means we have a definite biggest value. So my -1 is definitely going to be on the right. If I think about things being smaller than that, the smallest thing that exists there would be -infinity. I cannot include the -infinity, and the -1 is not included either. So it's going to get parentheses as well. Now x is greater than 6. Now I have a definite smallest value. It's everything that's bigger than 6. So 6 is my smallest. And the biggest thing that we have then would be to positive infinity. Again, neither of those is going to be included. So they both get parentheses.